So welcome to GMST Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study we are going to conduct experiment number 3. That is a parallel operation for two dissimilar single phase transformers. So we are using a two dissimilar means we are 2 kVA, 1 kVA or 5 kVA or 10 kVA like that. So transformer should not have the same ratings. So aim of the experiment is we have to connect a two single phase transformers of a different kV ratings that should be connected in parallel, and we have to study how they share a common load. So these are the apparatus required. That is, we require the single phase transformer. That is, the range should be 0 to 300 volts. Quantity is one number, and single phase transformers, that is 2 kVA one number and 1 kVA one number with the same ratio 230 by 230, 230 by 230. So one number is required. Total we require the two single phase transformers because we have to connect these transformers in parallel. Again, we require the AC ammeter, that is, it should be digital, and AC voltmeter also, and we require the multifunctioning meter and resistive load. So theory. So when you talk about the parallel operations of two dissimilar transformers that should be connected in parallel, and it is very tricky also. So due to their different impedance characteristics, which can be lead to the unequal load sharings. So what are the conditions are required for the parallel operation is the voltage rating. Ensure that the voltage rating of both the transformer are compatible and match the system requirement. So then we require the impedance matching. So that is the transformer should ideally have a similar impedance, the values that share the load evenly. If the impedance are significantly different, so one transformer can carry more load than the other transformers, potentially leading to the overheating and the inefficiency of the transformers. So next, the phase orientation. We have to check both the transformers are properly phased before connecting them in a parallel to avoid the phase issues and the potential damage to the transformers. So next, we require the another condition. Two conditions is that one is the same voltage ratio, there is a load sharing. When you come to the point of same voltage ratio, the voltage ratio of both the transformers should ideally be the same. Ensure the proper distribution of the load and balanced operation should be made. So next, load sharings. The monitor the load sharing between the transformer closely. If the significant difference in a load sharing are observed, additionally the measure such impedance matching or load balancing transformer may be requirement that is necessary. So this is actual circuit diagram. So in the circuit diagram, we are using a single phase auto transformer. Right, you can see this is a single phase variac. So this is connected to the our parallel operation of the two transformers. So here we can see this is the one transformer TF1 and this is another transformer TF2. Here we have the LV winding and HV windings. So this is P1 and this is P2. This is P1 and P2 for the T2 transformers respectively. So P1 and another of this P1 should be shorted. You can see this P1 and this P1 of TF1 and TF2 are shorted, connected to the auto transformers. Next, P2 and P2. You can see the P2 and this P2 are connected in parallel. It is connected to the single phase variac. On the secondary side, the output of the HV side of the TF1 and TF2, it is connected to the input of the multifunctioning meters, which is symmetric to the another transformers. Here also we are connecting the input to the multifunctioning meter. That is output of the secondary terminals of the transformer, that is TF2. Then output of the multifunctioning meter should be connected to the watt meter, or you can say the watt meters for M, and MNC should be shorted, and L is connected to the ammeter, and V is connected across the parallel to the load also. And here on the secondary of the transformer, that is output of the multifunctioning meter, we are connecting a switch. This switch is also connected across the switch. We are connecting a multimeter to check the voltage. So if the voltage reads 0, then you can close this switch. So you can see, you can close the switch. So if it reads double the voltages, then you have to change any one of the secondary terminals. That is S1 and S2 should be interchanged. Any one of the transformers should be interchanged at secondary terminals. Then apply the loads and we have to take the readings. So procedure, the connection should be made according to the given circuit diagrams. The single phase variac should be kept in the minimum position. Then a switch of single phase supply should be closed. Then slowly increase the variac to get the rated voltages, 230 voltages. Then you have to check across the, I told that the voltmeter across the switch should read 0. That is a switch K. Then we have to close the switch. So here, if across this voltmeter, this is our multimeter. If this multimeter reads 0, then we can close the switch. Right. So that is what in the procedure we are explaining. So the voltmeter across the switch should read 0 across the switch. Then you have to close this. If it reads double the voltage, then you have to interchange any terminals of the secondary of the transformers. Then again we have to repeat the step 3. So by loading, then you have to apply the load to the transformers step by step to note on the readings of voltage, current and power from the multifunctioning meter for the two transformers. Then also note on the V1, IL, WF from the meters connected to the loads. Load is applied up till the rated current of the till we get the rated current. Then note on all the values in the observation, make the tabular columns and note on the values. Then reduce the load step by step and bring back variac to the minimum position. Then supply switch is closed for the single phase auto transformers. Then we have to make the connection to make the short circuit. So this is our short circuit diagrams. We have to short on the secondary side, right? Primary side it is connected to the our ammeter, voltmeter and wattmeters, that is UPF wattmeters, right? So P1 and P2 are connected on the input side to the output of the auto transformers. It should be connected to the input of the single phase transformers via your UPF, ammeter and wattmeters, and secondary S1 S2 should be shorted. So for that procedure, we had refer the point number 8. The connection is made as per the given circuit diagrams. Then you have to conduct the short circuit by shorting the secondary side of the terminals, right? So then you have to take the readings. So this is actually tabular columns. We have to note on the I1, I2, W1, W2, IL, VL and SL. That is IA, IB, SA, SB and SL. So this is a short circuit diagram, and this is a tabulation for the short circuit test. So here we have note on the for 2 kV ratings, that is VSC in volts and ISC in amperes and WSC in watts. And for the transformer B, that is for 1 kVA, you have to note on the VSC in volts, ISC in amperes and WSC in watts. So these are the calculation part for the transformer C for 2 kVA. You have to find out the Z, that is VSC by ISC in ohm, and RA WC by I square SC. And to find the XA, we are using the under the square root of Z square minus RA square. So Z is equal to RA plus J should be in ohm. Or you can write in the polar form, that is R at angle theta, that is Z at angle theta. So this for similar for the transformer, we also uses this formula to find out our IB values and SB and WB also. The calculated values of IA, WA and IB and W are compared with the actual values of IA, WA, IB and IB respectively as shown in the tabular columns. When you come to the point of the results, the load current and power shared by transformers C and B is obtained for different load conditions. Thank you.
So today we are going to study the experiment on parallel operations of 2 dissimilar transformers of a different kV ratings. So after making the connections, we have to close the switch, right? So once you close the switch, you have to vary the single phase auto transformers to the rated voltage. So this is the voltage. We are going to vary the voltage from the single phase auto transformer to the rated value of the single phase transformers. You can see now it is 230 voltage. Right, after setting the 230 voltages, you have to check in the multimeter. So if the multimeter reads 0, right, so you can close the switch. So this is switch. If it reads double the voltages, then you have to interchange the secondary terminals, any one of the transformers. So now it reads 0. Now we can close the switch. We have to disconnect the multimeter terminals. So then close the switch. So once we close the switch, you can take the no load readings. So that is 229. This is your V1, I1 and W1. So this is your I2 and this is your W2. This is V3, I3 and W3. So let us take the no load readings first. So that is V1 is 229 and I1 is 0 because it is no load, and the W1 is 0. W1 is 0. Next, I2 it is 0. So W2 is 0. V3 is 229 and I3 is 0. W3 is 0. So now this is your first reading, that is no load readings. So this is your no load readings. That is V1 is 229, I1 is 0, W1 is 0, I2 is 0, W2 is 0, V3 is 229, I3 is 0, W3 is 0. So now we have to apply the load. So this is your resistive load bank. You can apply the load step by step. So now you have to take the load readings. That is, now after applying the loads, we have to take the readings. So now it is 228 and current is 0.365. W1 is 0.079. This is I2 0.54 and W2 is 124.9. V3 is 228. I3 is 0.6 and W3 is 0.152. Again you have to take the one more readings by applying the load. So once we apply the load, again we have to take the readings. That is 226. I1 is 0.742. W1 is 0.162. I2 is 1.08. WD is 246 and V3 is 226. I3 is 1.35 and W3 is 0.303. So this is your second reading, that is after applying the load. So now we have to off the load one by one. You have to off the load one by one. So now vary the auto transformers, single phase auto transformers. Then we have to off the switch also. So now vary the single phase auto transformers, bring back to the zero positions. So you can see the voltage is going to be 0. So we are bringing back auto transformer to the 0 value, 0 voltage. Right, now it is 0. Now we have to off the MCB switch. So thank you.